Good morning. Hope you guys are doing well. My apologies for this video being a little bit late today. With the 2-hour delay, I didn't have to come in as early, so that's why it wasn't there at 9 a.m. So thank you for your patience. It's going to be a short little notes day today. So let's go ahead and write the date. It's Thursday, February 11th, 2021. And we are going to be simplifying radical expressions. So your quiz on Wednesday or Thursday, depending if you're, and of course if you're Miller kiddos, you're going to write the 12th because you'll see this tomorrow. So this will also be on your quiz, but it's a very small part of it, and you guys, you're going to find it to be pretty easy. So let's just do a little bit of a, we'll call this a flashback. Oh, that's catchy, right? We'll call this a flashback for today. Okay, so remember back in elementary school, I'm even going to put some like flashbacky looking little triangles. Oh, that one's not good. Here we go. Remember back in elementary school when you had to find the factors of a number? So you did like an old school factor tree. You know what I'm talking about? So let's refresh our memories on what a factor tree is, right? So let's say you start out with the number, I don't know, 24, right? And so your teacher wanted you to find out, well, what are all the possible things that you could multiply to make 24? So you can start out with a couple different things. You can start out with 2 and 12. You can start out with 3 and 8, or you can start out with 6 and 4. I mean, there's lots, right? We're going to start out with 6 and 4. It doesn't matter what two products you start with because, two factors, because you're going to end up with the same factorization. So then 6 can be broken down to 3 times 2. And remember you would stop where you found your prime numbers, those numbers that can only be made by multiplying itself in 1. And then I would say, all right, well, 4 is 2 times 2. So no matter how you start out, if I started out with 8 and 3, I'm still going to end up with a 3 and 3 2s. If I started out with 2 and 12, I'm still going to end up with these numbers, right? So I've got these numbers here. So part of today's assignment is just making sure we can factor. That's going to be like the first step, okay? So then if I was going to show what my prime factorization was, I'd say, well, it's 2 times 2 times 2 times 3, because you want to make sure they're in least to greatest order, right? So that's our flashback for today, how to actually factor using a factor tree. So what we're going to do now is continue with simplifying radical expressions. So, and that requires basically doing factor trees. So we'll start out here. We just did 24, so let's take the square root of 24. And you're probably thinking, how is that the same? So we'll go ahead and rewrite our factor tree here. I've got 6 times 4, so I got my 3 times my 2, and I have my 2 times my 2, right? So those are my prime factors. So what I'm going to do then is take those and put them, this is going to take up a lot of space. We'll just go over here. Put them underneath the square root symbol. So what I've got is 2 times 2 times 2 times 3. This is equivalent to this, right? So we took our number, broke it down to the factors, and now we have these beautiful numbers under here. So what I'm looking for are pairs, right? So 2 times 2 gives me 4, right? That's a pair of numbers. That can come out, just one of the 2's, and then I have to keep this 2 times 3 under here, change that to 6, and this is my simplifying of my radical expression, right? So by taking this pair of 2's out, I have this 2 out here, and I have this 2 times 3 underneath because they don't have a buddy, right? So what I usually tell when I'm teaching this is look for buddies. If they have a buddy, it comes on the outside. If they're left alone, they got to stay inside, okay? So the way this works mathematically is if I were to give you this and I said, well, what does this equal? Well, this tells me it's 2 times 2 because I had the 2 2's out here. So I'd have 4 times the 6, and that would get me back to where I started. Okay, so I know that seems a little vague. Let's keep practicing. Let's do another example. So we are going to simplify square root of 150. Okay, so I'm going to do my factor tree over here a little bit so I have some space. So I'd ask myself, what times what equals 150? Well, there's multiple pairs of numbers, but we're going to go with 10 and 15. You could have said 3 and 50. You could have said 25 and 6. You're still going to get to the same prime factors. So then I would say, all right, 10 is made by 5 times 2. Those are both prime numbers. And 15 is made by 5 times 3. Again, both prime numbers. So then I'm going to go over here underneath my little square root house, and I'm going to put them in order from least to greatest. So I have 2 times 3 times 5 times 5. I'm going to look for a pair. Well, these 5s are a pair. So these 5s are now a single 5 on the outside, and I'm left with 2 times 3. So there's my answer. And so if somebody saw this, they would say, well, this must have started out as 5 times 5, which is 25. 25 times the 6 gets me back to this 150 under here. Okay? How are we feeling? Good? Good, great, grand? You want to see another one with just numbers before I throw in variables? I'm imagining that you're all going, yes, Mrs. Marsh, do one more, do one more. Okay, so we'll try the square root of, it's a good one. Let me see what else I have in here. I don't have that one. Let's do square root of 48. Okay, so I got my factor tree here. And there's lots of different ways I can make 48. I'm going to do 12 times 4. So 12 can be broken down to 6 times 2. 2 is a prime number, but 6 is not, so I can keep that one going. 2 times 3. And then 4 can be broken down to 2 times 2. So I have my prime numbers. So then when I do my fancy square root house, I've got 2 times 2 times 2 times 2. And then I've got a 3. Just that one 3 there. So again, I'm looking for pairs. So I've got a pair of 2s, a pair of 2s. So what I have now is 2 times 2, because each of these comes out as a single 2 with a 3 underneath. And then I have to simplify this, so my final answer is going to be 4 square root 3, because 2 times 2 is 4. So if somebody was looking at this and they said, well, what did this start out as? They would say, well, this is 4 times 4, because once it's taken out here, that means there was a pair. So 16 times 3 is 48, which is where I started. Okay. So now we're going to throw in some variables. Don't freak out. You'll be fine. I'm ready for example 4. There we go. So I'm going to have the square root of 12x squared. So I'm going to do the same thing. I'm going to take that 12, and I'm going to do my factor tree. I'm going to do 3 times 4. 4 turns into 2 times 2. So I've got my factors. The only difference now is that I also have to expand out this. So x squared, we all know, is like saying x times x. So what I have here is 2 times 2 times 3 times x times x. So I'm looking for my pairs. I have a pair of 2s, and I have a pair of x's. So I'm going to take the 2 out. I'm going to take the x out, and the poor 3 has to stay by itself. So there's my final answer, 2x square root 3. Pretty cool, right, guys? So we're going to start out where you write everything out, but eventually, maybe with the probably with the numbers, but when you get to the variables, you're going to be able to be like, all right, that's just an x coming out, or all right, that's just like 3 x's and a y. Because what we're looking for is an even exponent. That tells us, like, okay, there's 2 x's here, so I can take 1 out. If this was a 6, I would have x to the third, because I would have 3 pairs of 2 x's. Let's do another one. Let's do square root of 88, m to the third, n to the fifth. Okay. Hope you guys can see that. Okay, let me zoom in a little bit. All right, so the first thing I'm going to do is this 88. I'm going to go with 8 times 11, because it just seems like the easiest one. Then I've got 2 times 4, and then 2 times 2. So these are my prime numbers. So underneath my square root house here, I'm going to have 2 times 2 times 2 times 11 times 3 m's times 5 n's. Can I fit them? Ooh, that's a tight fit, but it's there. All right, so I stretched everything out. I'm going to look for pairs. I've got a pair of 2's. I've got a pair of m's. And I've got 2 pairs of n's. So I'm going to take out a single 2, a single m, and 2 n's because I have a pair of them. So that's going to be n times n. And then what's left underneath, what doesn't have a circle, is 2 times 11, which is 22, and then mn. And there's my answer. So really, if you can find pairs, you can do this problem. Okay. Let's do a couple more examples, and then we'll be all done for today. Not terrible, right? Could be worse. Okay, so what if we have a negative outside the little square root house? What if I had negative 20 m t to the 4th? So really, I'm just going to kind of ignore the negative, and I'm going to do everything else, and then just like put the negative with my final answer. So we're going to ignore it for right now. I'm going to find my factor tree for 20. Oops, what am I thinking? 5 is a perfect square. A prime number. So underneath my little radical house, I have 2 times 2 times 5 times m times t times t times t times t. Right? And like I said, some of you might already be like, I'm just going to take 2 t's out because this is 2 pairs, right? But if you need to write them out, that's fine. I'm probably not going to give you anything like extravagantly large so that you'd need like, extra paper. Okay, so I've got a pair of 2's and I've got 2 pairs of t's. So my answer is going to be 2t squared because the first t and the second t. And then I'm left with 5m hanging out by themselves. Okay, so we'll do one more. If I have negative square root 85 r to the 12th, m to the 9th. So I'm going to do my factor tree for 85. 5 times 17 works. Those are both prime numbers, so that's all we have there. So I'm going to do my house, excuse me. I'm not going to write out all those r's. I'm just going to put r to the 12th, and I'm not going to write out all the m's. I'm going to say m to the 9th. Because I know that how many pairs of r's do I have here? 6, right? So I've got r to the 6th. How many pairs do I have here? Well, I'm going to have 4 pairs of 2, so that's going to be, m to the 4th. And I can't do anything with this 5 and 17, so that stays as 85. And then I'm going to have a single m left because this would have been 8 of those 9 m's, so I have 1 left. And then oops, you guys, I forgot my negative sign up here with number 6. Don't forget to put that negative there. You're probably thinking, I need to send Mrs. Marsh an email. She forgot the negative, but I beat you to it. So then again, of course, I'm going to put this negative down here and then finish it up. So the negative should not scare you. It just goes back with your answer, and you can see how easy it is to forget that. So don't forget. All right, that's it for today. Next time I see you, you'll be doing a study guide, and then, of course, the next time after that, you'll have your quiz. All right, thanks, guys. Have a great day. Stay warm.